Omnivorous and carnivorous diets have now evolved independently in several viva lineages. In addition to the primitive ancestor of banshees, which first adopted predatory leanings, a group of seralopes, in order to survive in the harsh polar wastes, have since also developed generalist tendencies. Directly descended from the canary, which itself is still extant, the boarbird hunts the northern taiga and tundra region of striata, eating almost anything it comes across. Whereas the boarbird's ancestor ate mainly lichens and pine needles, the boarbird now favors meaty food, chasing down smaller birds, searching out carrion with a keen sense of smell, and also digging up tubers and gorging on seasonal gluts of seeds and fruit in the short Arctic summer, only relegating itself to grazing when other food is in short supply. The canaribou's small bill tusks have become tooth-like projections in the boarbird, useful to cut and dismember meat from carcasses and dispatch small animals. Its stomach remains chambered but shows signs of a reduction in complexity, shorter than those of other seralope, and the chambers smaller and less well defined, while the grinding plates on the front of its tongue have become sharper and pointed, in convergence with the banshee, as a bone-stripping tool. As spring thaws the tundra, an opportunistic boarbird feeds on carrion, perhaps a canaribou calf that has not survived the winter. The boarbird is smaller than its ancestor, lighter and leaner, and is solitary. Its wings are almost vestigial and of no practical use, with the spurs but a tiny claw and the primary feathers just a few wispy tufts. Rather interestingly, northern populations of boarbird still associate closely with canaribou herds, picking off weak and ailing young and feeding on voided eggshell fragments after chicks are born, which are frequently still well vascularized with blood vessels and edible tissue. The most likely origin for the boarbird is that a group of canaribou, facing a particular harsh string of winters, may have been forced to feed on their weaker fellows that succumbed to the cold in order to survive when plant food was unobtainable. Eventually, as the population became distinct, predation upon one another's living young may have been the next step, resulting in the solitary behavior of the modern boarbird, which retains cannibalistic tendencies towards offspring rather than its own. To get by in one of the harshest of all biomes requires complete adaptability, sometimes to a very extreme extent, if a creature is to survive. We are now 15 million years into the Cryocene, 65 million years post-establishment. The global climate on Serina has changed very little since the start of the Cryocene, but life continues to evolve. Geese continue to diversify and are now almost uncontestedly the dominant megafauna group on land over Serina's eastern landmass, as well as being ecologically diverse, if less monopolizing, in the west. High levels of competition between the different flightless canaries, both vivas and other groups, continues to produce waves of new radiations, as new groups diverge with increasingly complex specializations that give them just a little bit more of an edge against their competitors. The earliest geese were flightless, cursorial grazing canaries, which evolved within just a few million years on Serina's lush, grassy plains. They swallowed leaves, seeds, and strips of grass whole, tearing and pulling with a serrated bill, and practiced hindgut fermentation to digest it all. This primitive method of plant digestion is less efficient than rumination, but worked well for breaking down the coarsest plant foods, such as dry grass, and allow the animal to survive on a diet of lower quality than other herbivores could, by letting them constantly take in small quantities of food throughout the day. The earliest arge geese were thus mainly grazing animals, and had to spend almost all of their waking hours feeding to survive. The arge geese, in turn, gave rise to the vivas, which appeared now 40 million years ago in Serina's east. Defined by the coevolution of internal egg incubation and a primitive chewing ability, resultant from scraping a rigid tongue against the roof of the mouth, which improved their ability to digest tough plant foods. They too were herbivores, entirely flightless and well adapted to run. They developed more efficient digestive systems and chambered stomachs, and the ability to ruminate, regurgitating food back into the mouth and chewing it multiple times. Just as mammals as diverse as deer, giraffes, and even kangaroos, which also evolved the behavior independently, do on Earth, which no longer required they feed quite as often. The first vivas evolved as browsers, but some of their descendants reverted to grazing behaviors. Unlike ancestral arge geese, however, they were now more selective. Rather than feed on large quantities of whatever they could find, like a horse, they picked and chose only the most tender bits and the newest growth. Many earth ruminants have similar tastes, such as gazelles and wildebeest, which, despite being advanced ruminants, do still feed on grass, but in different ways than the zebras they coexist with. By 50 million years post-establishment, the vivas in turn had radiated significantly away from this ancestral niche and produced not only a myriad of new grazers and primitive browsers, but also omnivores and even a group of obligate carnivores, the raptorial banshees, which in multiple environments across Serina's east outcompeted other predators, despite being heavily adapted as herbivores due to the much more efficient method of rearing their eggs, which the group has evolved compared to other birds, a great advantage in cold climates. In the common ancestor of the omnivorous group, which diversified into animals as distinct as the banshees and the shimmer snout, the chambered, complex stomach rapidly and dramatically reduced in size and length, for a diet of animal protein is easily broken down and indeed can sour if it stays in a lengthy digestive system for too long. Carnivorous vivas did not lose their modified chewing tongues, though. Rather, in the banshees, the organ became armored in barbed spines, a tool perfect to strip flesh from bones, while in the shimmer snout, it became a bony implement to pulverize mouthfuls of ants and break up their exoskeletons before swallowing them. Now 65 million years have passed since the canaries were introduced, and the vivas have given rise to another highly successful lineage, the seralopes. Seralopes evolved initially as one of those selective grazers just touched upon above, but notably have evolved the most efficient chewing apparatus as yet evolved in any bird. The tongue is large, strong, and highly muscular with a bony core, and is covered upon its upper surface in a series of keratinous plates which mimic molars and grind in a circular motion against a series of similar plates that cover the roof of the mouth. As an advantage over mammals' teeth, the seralopes' tongue and jaw plates don't wear out, as they constantly grow outwards as they are worn down through the process of chewing. To prevent food from falling from the mouth, and allow the seralope to chew, swallow, and then regurgitate mouthfuls of food to chew again as it ruminates, they have evolved fleshy cheeks that run along most of their jaw. The jaws are almost completely soft and fleshy, with gums which were once a hard beak, save for multiple rows of tooth-like keratin plates in the upper jaw. Indeed, while the beak of most vivas still covers most of both jaws, on seralopes it now only covers the very distal edge of the jaws and functions only to crop plant material, like a set of incisor teeth. Seralopes evolved in the northern plains of Serina's eastern continent, but rapidly spread southwards and now cover the entirety of that continent. On the top, a banshee, a specialist predatory viva, showcasing its barbed, flesh-stripping tongue. On the bottom, a seralope, a specialist herbivore viva, showcasing the skull and bony grinding tongue jaw and extent of soft tissue. Seralopes were the first canaries to produce true live birth, but the retaining of the eggs inside the mother's body until after hatching, a seemingly simple step that marks the final culmination of the process of internal incubation, will over time occur again in other viva lineages. A drama unfolds on the lush, temperate highlands of a mountain range in equatorial Walteria, 65 million years post-establishment. Two strange, colorful creatures engage in a race for survival as a predatory viva pursues a vegetarian relative. Both males, and more colorful than the females of their respective species, both animals are adapted to endurance running, with lean figures and very long legs, making this a race whose outcome is very much up to chance. The prey animal is a member of a primitive lineage of seralopes known as Flutterboks, highly dimorphic herbivores with colorful, long-plumed males and dull-colored females whose wings and tails are short and stumpy, in sharp contrast to the long, colored feathers that adorn their mates' bodies. The dimorphism is due to the fact that the males are highly polygamous, competing with their colorful plumage and elaborate dances to breed as many hens as possible. The flutterbok is mainly a low-level browser, feeding on tall grasses, sunflower trees, and dandelion shrubs, with well-developed chewing abilities and a tiny, reduced bill with spacious cheeks to accommodate this. The predator is also a seralope, albeit one which has evolved into a dramatically different niche. The third lineage of carnivores to evolve in the vivas, Trunksnouts, despite their funny appearance, are a group of cunning and almost completely predatory animals. Unlike the primitive banshees with their long, open jaws, this very derived group diverged after the evolution of cheeks in their herbivorous ancestors, and in addition, males sport a large, inflatable trunk on their snouts, which is used in their own courtship displays and to amplify their calls. The tongue jaw is well developed and contains the most specialized keratin teeth of any viva. Most notable are two pairs of pseudocarnassials on each side of the tongue and the upper jaw, which work together in a shearing motion particularly effective at chewing meat. This particular species, the saber-toothed trunksnout, does not actually utilize its sabers to hunt at all. Rather, they are weapons for intraspecific fights against other males and, like the trunk and bony ossicones of the head, are absent in the female sex. Trunksnouts are often social, hunting cooperatively with a mate or a small pack, in which case they may operate as a relay to run prey animals into exhaustion. Prey is disabled with a crushing bite to the windpipe, which is particularly damaging due to a combination of a sharply hooked bill and the jagged teeth that line the jaws. But a group will start eating as soon as it stops struggling, whether or not the victim is actually dead. Though they can and do hunt other large flightless birds, a substantial part of their diet still comes from small animals and carrion. Trunksnouts are opportunistic, and though their digestive system is very short and no longer suited to eat grass, they will also eat certain seeds and fruit, whether they come across it. Carnivory in the trunksnout first evolved at the end of the Tempocenic era, 40 to 45 million years post-establishment, by which time the first recognizable cheeked seralopes had just diverged. Judging from their jaw morphology, their earliest ancestors likely fed on aquatic vegetation, gradually including aquatic animals in their diets before moving to carrion and living terrestrial prey in a very rapid progression of under 10 million years. Upon evolving the shearing teeth, which make them especially effective predators, which have their basis in sharply cusped structures likely used to crush the shells of crayfish and freshwater invertebrates. Their group has since been evolving and diversifying at an exceptionally rapid rate and spreading both northwards and southwards, and shows a high degree of evolutionary potential.